your consultancy, Advanti, that you founded it right out of school.
As you start to build your product, like customers don't expect, if you're providing them a solution, like the way I think about it is that there's a problem and there's a solution. And sometimes that solution, it doesn't have to be 100% product. It could be product and a service. What did you know on that particular day? And this is where the temporality comes in, where you have to understand, like, what has changed.
Doug, welcome to the program. I'm so excited to have you on. We've known each other for a couple of years, and you're just such an ideal podcast guest where the audience is so lucky to have you here. They don't even know it yet. So welcome, Doug. Where in the world are you today?
Thank you. I am very happy to be here. I am in Natick, Massachusetts, which is like 25 minutes outside of Boston. Great place to be. Very close to the highway, and yeah,
that's what you want. That's really cool. I am, if the people are watching, if the listeners or viewers, I guess, are watching the YouTube version of this for the first time since I started hosting the Super Data Science Show on January 1st, I'm in a different room. So I'm traveling for the first time since the pandemic started. Things are starting to open up across the US. And so it was the right time for me to visit our company office in Austin, Texas, which I'd never been to. And I'm in my hotel room right now. Austin, Texas, is a really nice place to visit. People are really friendly here. Have you been, Doug?
I've never been to Austin, Texas. I have not been to Texas at all, but it is on one of the places that we'd like to visit if we take one day our RV trip from Massachusetts all the way out to Arizona, which we've talked about many times. That will happen one day, and our stop, that'll be one of our stops.
Yeah, it's very cool. Lots of great food, people extremely relaxed, and an enormous tech hub right across the street. I can see it out the window right now. I'm looking at Anaconda headquarters.
Wow.
So the people who make like the Python package and associated libraries.
Yeah.
So there you go. Some little data science nerdy.
Data science right outside your window.
Exactly.
Some inspiration.
Yep. So we've known each other for a few years now. I remember you visited an office that I was in like, probably 5 years ago kind of thing, through a friend of a friend. And we really connected on things like CrossFit. You're wearing a Rogue Fitness shirt, which is a big brand in the CrossFit community. And yeah, we've stayed in touch. So that's really cool. I actually, something that I didn't really specifically know about you, but when I was researching for the show, I discovered that your consultancy, Advanti, that you founded it right out of school. So in 2002, you transitioned from a bachelor's degree in computer engineering straight into your own company. Tell us a bit about that. So you can, tell us a bit about what Advanti does today, but also how you had the guts to make that jump to create your own company right out of school.
Well, I'll tell you, I'm going to rewind back for a minute because I'd like to joke around that the reason why I am where I am today is because I had a passion for video games growing up. Like, no doubt. That like screen time and interest led to like tinkering, and that tinkering led to like building PCs and stuff. And then from there, getting into college. And, it just kind of happened that from when I was 16, I knew that my path, like I see with my kids, like you begin to know what your gifts are. Like you see that in yourself, oh, I'm really good at this. I'm a natural at this. And I saw that in myself. So as I started to go through college, at that time, that was the late 90s, early 2000s. And it was like the dot-com boom at that time. I was working at like a .com place. Oh, I have such great stories to tell one day that over drinks, myself sleeping inside of a data center for basically 3 days because we had so much traffic and I was trying to figure out how to scale all of our web services at that time. Like great stories, but I kind of found that I liked working on different projects, working with people, understanding their businesses and understanding like no matter if you're focused on one industry or multiple industries, I think the opportunity that you get when you do consulting is that you have the ability to really understand how their business runs, how it functions, the different kind of systems that are put together, and you do see the similar kinds of problems, whether it be industry specific or agnostic. And I mean, I just kind of found myself going from Suffolk into working at these .com startups at that time. And I said to myself, actually, I was working as a consultant with another friend of mine. I think he had decided to work full time at another company. I ended up working as a consultant for one of his clients. And then from that point, I'm like, I kind of like this, let me just create a company. And it was just initially me. Where this really started to kick off that was interesting was the hardest part of doing all this. The hardest part was that in the very beginning, when you don't know anybody, you have no track record, you have no one but you at your company. Your company is you. Like, how do you get customers? So going from 0 to 1 was a very difficult challenge. I remember going to customers and telling them, hey, I can help provide all of these different data services. And what ended up happening was they would say, okay, well, what people do you have? And I kind of like just think, I don't really have any people, just me. You needed somebody to trust you. And I had a couple of people that trusted me, and that really helped me open up that door. And then once I had one person that trusted me, I did the best job that I could. And from that point, it just became all like word of mouth and really went from there.
Nice. That's a really important part of the story to highlight. And you mentioned one of the things that you mentioned there was Suffolk. And for people who don't know, that's the university that you were studying
Yes. Yep.
computer engineering at. That's also in Massachusetts, right? Where you live?
It is downtown Mass. Actually, they're really well known for law. One of the things I look back on is, maybe I should have got a law degree, and because I have friends of mine that are like, understand patent law and that whole like legal tech space is pretty neat.
Yeah, different strokes for different folks. I could not imagine being a lawyer. That does not sound like fun to me, but obviously for somebody it is. All right. So Advanti, you started it almost 20 years ago now.
Yep.
And nice to hear a little bit of the backstory on getting going with that. Has it always had a focus on finance? So making data useful in finance like you guys do today?
Very early on, no, actually. My journey in the very beginning started, believe it or not, in just pure infrastructure. So infrastructure meaning like at that time it would be hardware, server administration, those kinds of things. But I always had a passion for data, and I remember distinctly there was a buddy of mine who was a database administrator at the time. Started talking about like column stores, and I'm like, wow, this is really cool. So I put all of my energy into learning about that and transitioned the company probably back in 2007 to more focus on data. And from focusing on more databases, we kind of, I don't want to say fell into finance, but it just was the fact that we started working with some finance companies. They were hedge funds. CTO of one of the hedge funds goes to work at another company, calls us, asks for help. We go there, and that word of mouth kind of spread from that point. So we went from actually infrastructure into more like what I call data infrastructure first, performance tuning systems. And then eventually that became into, well, it's the performance problem really wasn't necessarily in the hardware or optimizing like the data model itself. It was more of the kind of the transformations or the analytics that are being done and how everything was really connected. So it kind of naturally progressed into that area. And then it allowed us to see, going to work with so many different investment management companies, really allowed us to be able to see the types of problems that they had in acquiring their data, integrating it, analyzing it, and that led us to where we are now with Advanti Consulting, and then also with Aristos as well too.
Yeah, so I guess we could kind of summarize that what Advanti does today is this focus on data engineering in finance. So all of those kinds of different activities around having data flow efficiently, having different data sources reconcile against each other, all of that data engineering is really the focus, right?
Yeah, and that's actually still to this day a huge problem. I mean, I know that there's a lot of people that still say that data preparation is a problem. It is a problem, and especially within finance. I mean, in all seriousness, like it's still such a huge problem because there's so many hundreds of different data sources, even internal ones, that you still have to do all that integration with. That's still a major problem. It's got simpler with the great technologies that are out there, open source technologies. One thing that we try to focus on are using open source technologies as part of the solution that we provide to customers. But that the tooling has been fantastic. Like there's so many, it seems like every week we'll say, I talk to someone and there's something new that I'm like, oh, I got to check this out on GitHub. I start it, fork it, and then kind of like start learning about it. There's always something new that exists, and figuring out ways to, where does this technology fit in? One thing for the audience that also take into consideration as part of, like services and consulting is that you have to focus on the problem and really understanding what the problem is, because you have to understand what the array of modern tooling is and solutions, but more so, what exactly is the problem? What are the pain points? What are the needs? What are the requirements? Without even mentioning a single technology. And once you can do that and you understand that really well and you can articulate that, then you can start figuring out, okay, what tools do I use and how do I apply them?
Cool.
Eliminating unnecessary distractions is one of the central principles of my lifestyle. As such, I only subscribe to a handful of email newsletters, those that provide a massive signal-to-noise ratio. One of the very few that meet my strict criterion is the Data Science Insider. If you weren't aware of it already, the Data Science Insider is a 100% free newsletter that the Super Data Science team creates and sends out every Friday. We pore over all of the news and identify the most important breakthroughs in the fields of data science, machine learning, and artificial intelligence. The top 5, simply 5 news items. The top 5 items are handpicked, the items that we're confident will be most relevant to your personal and professional growth. Each of the 5 articles is summarized into a standardized, easy-to-read format and then packed gently into a single email. This means that you don't have to go and read the whole article. You can read our summary and be up to speed on the latest and greatest data innovations in no time at all. That said, if any items do particularly tickle your fancy, then you can click through and read the full article. This is what I do. I skim the Data Science Insider newsletter every week. Those items that are relevant to me, I read the summary in full. And if that signals to me that I should be digging into the full original piece, for example to pore over figures, equations, code, or experimental methodology, I click through and dig deep. So, if you'd like to get the best signal-to-noise ratio out there in data science, machine learning, and AI news, subscribe to the Data Science Insider, which is completely free, no strings attached, at superdatascience.com/DSI. That's superdatascience.com/DSI. And now, let's return to our amazing episode.
great summary point on how to consult effectively. And yeah, it is super cool how there's this growing and growing and growing open source community that is even now supported by the big tech companies. They have so many internal open source initiatives. Um, it's a wonderful time to be in this industry,
Yeah.
to be in data science or anything related to data software engineering. So you mentioned briefly there a couple of thoughts ago, you mentioned Aristos, which is another company that you founded.
Yeah.
And that was in 2020,
Yeah.
very recently. So just last year.
Yeah.
And Aristos makes products. So you have Advanti, which does consulting. And I love this. It is my number one recommended way to grow a business is to start in consulting, make some revenue doing that, figure out where people's pain points are, where the opportunities are, and
Yep.
then through working with clients, eventually you kind of have these ideas, maybe in the shower or whatever, you're like, huh,
Yep.
you know, clients X, Y, and Z all have this same problem. I could make a product and sell it to clients
Yep.
X, Y, and Z. And then who knows how many other clients could be out there. And that, so creating these software products scales a lot better than obviously consulting possibly can.
Yep.
So that's what you've done.
I mean, you hit the nail on the head with all that. That is exact. Like, you hear these stories about companies, products that are started from consulting, and I echo your comments. I mean, if you want to build a product and you really need to understand these pain points that customers within a given segment are experiencing. And what I have found in building a company is that you can focus on the market of of thousands, tens of thousands, of companies, but you really narrow it down to one little segment, a couple of pain points, and then if you don't understand those, if you don't understand those problems deep enough, and you need the systems, you need the people, you need the network, you just need to like have some way of starting, then consulting in one of these areas, consulting and starting to build an understanding of what the problem is. You work at one company, a second company, you do piece everything together. And actually, funny enough, yes, it's either in the shower or it's walking.
Right.
Or sometimes it's even like in the middle of a workout where you get this like,
Yeah.
not always though, sometimes you're just like, I want to get through to the very end. But you just get these eureka moments, and then, you jot them down and like, wow, like, that's what I got to do. And then the fun starts, because then you can start creating, you can start sharing. And the other good thing about doing the consulting part in the very beginning is, as you start to build your product, like, customers don't expect, if you're providing them a solution, like the way I think about it is that there's a problem and there's a solution. And sometimes that solution, it doesn't have to be 100% product. It could be product and a service. But as long as you're providing some kind of solution, so if you can emphasize what the solution is, you go to a customer and you provide them with a framework. And even if the framework provides out of the box 20% instead of the entire 100% or 80%, it gets them further. And if you can provide it for, you can work out some commercials that are good for the customer. Sometimes at the beginning, you might even just want to include it at no cost, but then walk away with the intellectual property of adding to it. That's a great way to be able to get started on building something incrementally. At some point, why do you build a product? You build a product because you want to be taking that and you want to be able to scale. Just like you said, you want to go from a consulting business, which is classically not necessarily easily scalable because it's people bound. And it's also, you have to monitor the quality of what is produced, and people producing different quality solutions to something that's more process oriented to something that is an actual product.
Yeah, that's really well stated as to why consulting doesn't scale as easily, is that you have differences in quality With each person, it needs to be monitored. Cool. So you have now a number of products at Aristos that grew out of this kind of approach of realizing where pain points were from consulting. And so I think there's four, right? So you
That's
have
right.
Dominus, that's an entity recognition engine. Tell us about that and the
Yeah.
other three as well.
Yeah, so we found these gaps basically. One product that we've created is called FinFlow. And FinFlow, if you ever heard of a product called Stitch or even Fivetran, it's very similar to those products, except it's specifically around finance. And one of the problems within finance is that you have hundreds of different data sources, and oftentimes these organizations are getting the same data, building up the same process to pipe through all the data and get it into a usable form. The purpose of these, of what we call these adapters in FinFlow, is to just start flowing data from point A to point B, and point B could be, any kind of modern data warehouse. So that's the scope of FinFlow, turnkey data adapters. Then comes, all right, cool, you got everything and sitting inside of one place. Now you need to start linking everything together. And this becomes probably one of the heart and soul of what we've created. And one of the biggest problems that I think is in finance, but also across other industries. And it's really managing what I see as entity data. Entity data meaning within finance, specifically the investment space, you can, if you're looking at equities and you want to be buying and selling a stock, well, a stock, you have to be modeling this correctly. And there's different kinds of identifiers, data from different sources. You get data about the price of a stock. You get data about the the fundamentals, or in other words, that's the cost of goods sold, the total revenue that comes at the company level. These two, just that simple example, are two different. They relate. They're two different entity types that have metrics that are very important for making a investment decision, but come from different sources with different identifiers, and those identifiers change over time due to corporate actions. So connecting all this together is absolutely crucial to making a good investment decision. And Dominus basically does the matching, the mastering, so combining the different attributes together and handling survivorship, and then the traversing. So you can say something like where you can basically go through a network graph or go through a knowledge graph and then get back the data that you need. So S&P 500 has members, and then those members can have a company. And then for that company, maybe it sells vacuum cleaners and you have rating information on vacuum cleaners. So you want to get all of that data together inside of a time series so you can perform analysis on it. The third is backplane. Basically, it's a modern way of handling your data infrastructure. So if you wanted to take your data adapter and run that on a Lambda or on Kubernetes, it handles basically decoupling your data infrastructure. And the last one is called Fabric, and Fabric is all about in the financial industry, there's since there's so much complexity in accessing the data, there are companies like Bloomberg that which is a financial data provider, probably one of the most well-known. They have a really cute language called BQL, Bloomberg Query Language. And it is so powerful and it does so much. So we've built something that is similar to that, where you can create your own DSL, your own domain-specific language, and you can basically define and say, hey, this is how I want to get the data out from my different warehouses, and it pushes the aggregations, the analytics down into the warehouse, and it allows someone who's a portfolio manager or a trader not to have to know as much about how to get the data out. So those are the four different products that we've created.
Cool. Thank you for that rundown, Doug. And it does provide me and the audience with a great sense of where some of your expertise lies. So, speaking kind of generally about finance and financial data, it might be helpful to break down the different kinds of financial industries.
Yes.
So, I know there's capital markets, asset management. I'm sure they all have different kinds of data needs.
Yep.
So, if you wouldn't mind breaking down those
Yeah,
different industries.
totally. Yeah, the way that I think about this, it took me a while to kind of think of it this way, but it makes I'll explain it. So I think of the financial industry as financial industry is being broken down into basically like banks, capital markets, credit, and then if you go further in, then within, let's say, capital markets, then you'll have investment management. And within investment management, what is investment management? Investment management are basically companies, I think there's about 16,000 worldwide, that will manage a large amount of money, millions, billions, usually billions of dollars on behalf of another institution. So that could be like the state of California has a retirement fund and they're going to allocate a portion of their fund to a hedge fund or to some kind of money manager. And that money manager will manage that money on behalf of them. So within the investment management company, there are what they call the front office, the middle office, and then the back office.
Right.
And the front office is where if you start to peel that onion back more, you have portfolio management and portfolio construction, you have research, you have trading, and that's where a lot of the investment decision making is done, and where I see more a lot of emphasis has been put in those areas over the last 5-7 years around kind of managing and improving all that data pipelining in those areas. That's kind of how I would see it. Looking at the finance, taking a 1,000-foot overview of the financial industry and kind of zooming into this area.
Nice. That was a very clear explanation. So, your expertise seems to be particularly helpful to this front office side, to the investment managers, the traders themselves. So, these are people who, while they're quite intelligent, while they might work long hours, and while they have a great understanding of the financial industry, they may not be able to write any code. So they probably spend a lot of time in spreadsheets. And there's this opportunity to present them with huge amounts of data that allow them to make better investment decisions. You already mentioned there's, a given single company will probably have hundreds of inbound data sources. And you can't expect the investment manager to be creating Python scripts or SQL queries to grab data from all these different sources and then merge them together and be able to see them in one place. So that's kind of where your sweet spot is, right? Building tools that allow these investment managers to quickly and easily make sense of huge amounts of information across many different sources.
Yes, exactly. Yeah. And I can just elaborate on the kinds. So in the front office, which happens to be the area that we do the most work in, the first component of that is that there's a research function within these organizations that needs to determine, they need to take data from hundreds of different data sources, connect it together between that department and usually some kind of data engineering department, and then put it into this form, this time series form, where they can start to make predictions on that. Within in the investment space, by the way, I didn't make this distinction before, but there are systematic investors and non-systematic investors. So a systematic investor would be what a lot of people hear about as being quant. In between would be called the quantamentals, and then over on the and then on the other side would be fundamental. So I've seen much more budgeting basically being allocated to even these organizations that have traditionally been fundamental, kind of trying to move into more of a systematic based process. But some of the problems that they have is that, you just want to be able to start, you want to get the data together. That's like problem number one. And I think a lot of these organizations, one of the pain points for them has been, many of them have been around for, decades. And what happens is that you start small, right? You start small with a small team. They grow their assets, what's called their assets under management. So the money that they're managing on behalf of their clients, that grows and grows. Their team grows and grows. But then the technology that they use might be this, at the core of it might be the same kind of technology that they had been using 5, 10 years ago. And without looking at creating a really solid foundation, that can sometimes be a big lift. And where we can come in to play is when a company has sort of matured and needs to take another look at their foundation and how they could sometimes modernize that, or make the onboarding of new data sets a little bit faster or more accessible, those kinds of things. Having a second set of eyes that has seen other companies go through this transition and sort of a fast way from moving from what you currently have into something that can take you a little bit further forward in the future. It's challenging for these companies to go and to migrate. So you need sometimes a migration path, and need to sort of think through with someone that understands your existing process, your unique investment process, how you can make that shift. And I find that that's where we find ourselves, at least from a services perspective, that's where we find ourselves often.
Nicely described. Completely understood. And so I imagine that one of the particular issues that happens as a company moves from kind of the non-systematic fundamental based trading,
Yeah.
where you're trading based on, reading news articles on, oh, electric cars are going to be big. So we should invest in Tesla. So that kind of fundamental stuff, moving from that through to quantamental, and then the totally systematic, quantitative, automated, data-driven type of company. Probably one of the biggest issues that companies could encounter as they make that transition would be around entity extraction and resolution.
Yeah.
So tell us a bit about that particular problem.
Yeah, so I think one of the problems is when you're getting hundreds of different data sources. Maybe even just thinking about this as like I want to try to be a little bit more concrete without going. Let me be a little more concrete. So when you're making an investment decision, sometimes what you need is, okay, let me take a step back. So there are different kinds of asset classes, right? So an investment manager sometimes is bound to a particular benchmark. So you can be bound to, let's say, the S&P 500, and your goal is you have to beat the S&P 500. S&P 500 is composed of stocks, right? There are all different kinds of investment managers and all different kinds of financial instruments that can be traded. Financial instruments, asset classes, they largely mean the same thing, at least how I'm speaking about it. Mm-hmm. And some of the problems that happen are that one of the hot areas now, past few years, has been multi-asset class, right? So multi-asset class means that you could be investing into stocks, into bonds, into futures, into swaps, all different kinds of unique instruments. So with that, you might have data that comes from the SEC. The SEC, is a regulatory body in the United States, SEC.gov, where companies that are public need to file what's called a 10K or a 10Q. So these are statements that are basically like the balance sheet, income statement, and you need to get those figures out of those filings. Some companies do that directly. Some companies buy this data from a market data provider. So you need to get that out. Now think about this, right? Like that is coming at the company level, right? That comes at the company level. Companies change over time. There are mergers, there are acquisitions, there are spinoffs. So keep that in the back of your mind. The second is you might be getting estimates data, data that comes from brokers or other companies like Estimize that have more crowd-funded or crowdsourced estimates. Then you have prices about the stocks. Then you have more alternative data sets now, which there's a proliferation of so many great data sources. You have email receipts. You can go to Glassdoor. You can get data from ThinkNum, from Quandl. Like there's just hundreds of different data sources. So the problem, going back to the entities, is that when you start to look at the data that you're being provided with different kinds of identifiers, different types of characteristics, and there's really different entities that are baked into that data. So you might have an index. An index would be the S&P 500, but you might also have an ETF, which is what could be like the spider, which would be the S&P 500 ETF. Then you can also have a futures contract. So you have all these different kinds of entities. They're providing you unique metrics. They need to be connected. And what we found, and if for the audience that's listening to this, that knows anybody in finance, knows anybody in the investment space, you should ask like your buddies, is this problem of like matching up identifiers and connecting all these different IDs together over time a problem? We've seen this as a huge problem, and that's one of the areas that we find is the most challenging for customers to really get right. So we spent a lot of time working on that and have actually created a tool that has helped us with that. Inside that tool, we're doing entity resolution, which has been entity resolution. What is entity resolution? You bring together, you're basically taking all these different data sets, you're extracting entities. The way that we think about it is that there's an entity has a identity, something that uniquely describes it, but it's so critical that you capture the descriptive characteristics, these unique characteristics, name, country, currency, might be CUSIP, CDAL, ISIN, which are different identifiers. And you have to capture that at a given point in time. Then once you can do that, you want to link them together. And that's where, as we think about it, there's a resolver kind of function. That's at least the way that we put together our component, where you can instruct the system with a plugin and say, hey, this is how you want to connect everything together. The whole purpose of entity extraction is really to increase the coverage of your data, like making sure that you have the highest coverage possible across all of your across your entire what they call investable universe. So your investable universe could be 500 stocks. It could be 40,000 if we're talking about equities. It could be in options, thousands of different financial instruments. So you want to cover, meaning if you have data from source A, B, and C, you want to try to cover as much as you can across every one of those sources. And sometimes it comes back to the linking of identifiers and characteristics together.
Nice. So I think I understand all of that clearly. So this idea of entity extraction generally means pulling specific nouns
Yeah.
from natural language documents. So
Yeah.
things like SEC filings. You have this big unstructured blob of text, and you scan over it. You identify words that are likely to be important entities,
Yeah.
nouns in the investment world. And then once you've extracted these entities, you
Yeah.
need to link them together. And so the example that you gave was, so the S&P 500, this index of 500, I guess,
Yeah.
big stocks in the US. And then there's the associated exchange traded fund, which allows somebody to very easily trade a single equity product that mimics that entire basket of 500 stocks.
Yeah.
And by the way, I think that's a great investment strategy and one that I use myself. And so those ETFs, they'll have a separate name. So, like you said, Spider for the S&P 500 is a stock that is abbreviated to SPY.
Yeah.
And so we need to extract things like S&P 500, SPY, and treat those as separate entities.
Yeah.
One of them being the basket, the other one being this single equity that we can use to trade that basket, and you want to link them together. And I guess when you link them together, you could use a structure like the knowledge graph that you mentioned earlier in the episode. Cool. And if listeners want to learn a lot about knowledge graphs, you can check out a recent episode 479 with Maureen Tessier, which was focused on exactly that. Anyway, so yeah, very cool. It sounds like you might have something to say, and I just keep speaking over you.
No. I think and you hit the nail on the head. I mean, that is the way to think about all this. And by the way, that is a great episode. I listened to that the other day, and it's very. In listening to Maureen, it was like, I'm like, wow, there's so much overlap to the way that the problems that I see not within real estate, but within finance. Like, I see a lot of these same problems. But yeah, man, I mean, like, same thing. Like, you have, it's the way you describe it is right. Like, you're searching through documents, through structured data, semi-structured, unstructured data. You're picking out these different entities. Sometimes you don't know what these things are, but the more information that you get, then the more you can determine. Oh, okay, we're really talking about Apple, the company. Not necessarily the apple that you're going to be eating. And there's different kinds of apples.
That
right?
famous apple harvesting firm that's listed in the S&P 500. So cool. There is something that you touched on earlier that I'd like to dig into a little more.
Yeah.
It sounds like it would be a particularly thorny issue. So when we're doing this kind of entity extraction, there are especially weighty complexities around temporal resolution. So that must be something that you really need to focus on yourself and get right.
Yeah, actually, temporality, I would say, is such a huge problem. The reason why it's so important, I've asked myself many times, why is it so important in this space of investments? You know what it is? It's because you want to look back in time and see, like, what if analysis? How did my portfolio perform? A simulation. Right. Sometimes people call it a back test. That's really the reason why.
Yeah.
And like,
if you throw those out, if you say, well, any company that's had a merger or an acquisition, that's too complicated, I'm not going to put it in my data set. That's a really big problem because those stocks in particular have some of the biggest price movements.
Yeah, exactly. And actually, with that, one other connecting thought to this is what people have told me that's different about finance is, let's say these 500 companies. So within S&P 500, you have 500, sometimes right around 500, but let's say 500. You need to have like 99.9998% or 100% coverage across all of your data sources, because there are times when you want to make a trading decision on one of those securities, and it just so happens to be a security that it went under some sort of what they call a corporate action. Is corporate action in finance just means like it's a merger, acquisition, spinoff, something like that. But those are sometimes the ones you want to take advantage of as a trading opportunity. and the data is going to prohibit you from that. So one of the issues is with the temporality is that when you're getting this data, the data can change. So in a super simple case, there is a company called Refinitiv, Thomson
Right.
Reuters.
Yeah.
They provide estimates data. And what would happen if an estimate that gets provided to you today on June 18th, they find out that the analyst made an error, right? Then you made a trading decision today using that data. On Monday, then you get an update that says, oops, there was a mistake. We've corrected that, right? And then you make another trading decision. Well, if you want to go back in time, you really need to look back and say, what did you know on that particular day? And this is where the temporality comes in, where you have to understand, like, what has changed. So there is a concept called bitemporality, which is very important, where you have like the dating around the date of the data itself, and then you have the date of when the data on that day has changed, and you track the different versions of that. So I think the temporality is such a key area, but the problem with the temporality is that in order for you to your pipeline that you manage needs to be taking that into account from the very beginning. Like, I've seen all different kinds of implementations, but you really have to know when you're getting your data from the very beginning and keeping track of the changes that have occurred to individual entries inside of that data, whether it be an API call or something else. You have to be tracking that. The last thing I'm going to say is I think of there being 3 different kinds of temporalities, actually. One temporality is the date, what some people call the data date. So if you think of a price is provided. Let's say you have a close of day price for the ETF of the S&P 500 today, right? Well, the close price is for today, so we'll say that's our effective date. But then when is that really valid? It's not, if you look back in time, it's not valid of today. It's really valid as a close price, after market close or tomorrow or, basically on Monday. So that's the validating. And you have to take that into account of those 2 pieces. Then there's the other dimension that I was mentioning. Some people call it the system dating, or we call it the knowledge dating, which is on Monday when Friday's data is valid, then you got this correction and now the data has changed. One last thing related to this is macroeconomic data, which is another, there's another example of where temporality is absolutely crucial. If you were to look at FRED, or you were to look at the ONS, which is the United Kingdom Office of National Statistics, I believe, and many other macroeconomic sources, they do keep track of usually what's called a release date, and then then like the data or the effective date. So they keep track of the 2 dimensions because they want to provide you revisions which are different than corrections to the data. So temporality, in order for you to be able to rewind back time and see what did the world look like and have a precise answer to it, critical.
I think I got it. So, first of all, it's crystal clear why this is such a thorny problem. The bitemporality piece is, I guess, something that a lot of other people talk about. where I wasn't familiar with it personally before, but it sounded like that's kind of the way you phrased it. So
Yeah.
that's a problem where you have the data. That's like one of the aspects that we're considering temporally, but then it becomes bitemporality because we also need this kind of metadata around when there are changes
Yeah.
to those data going back. And then tritemporality, which sounds like it might be your turn or a lesser
Yeah,
known
I don't think
term.
it's an industry term. I think it's probably my term.
So tritemporality has both of those facets. And in addition, it takes into account this everyday lag
Yes.
between, so you have like, the close price of a stock today, but you don't actually know that officially until the next trading day, which today is
Exactly.
Friday. That's Monday.
Exactly.
Cool.
Now, I could blow your mind, and I can add a couple of other dimensions because there are other dimensions to this. But there are other types of, I won't go into details, but there are other types of timestamps that are useful but not as critical. I'd say the two most critical ones are this, like the trade, either the trade, what people call the trade date or the price date or the effective date, and then this system date or what we call as the knowledge date. Like those two different dates are critical because that's how you can track over time, how your data, how these different data points have changed. And believe me, actually, what's kind of interesting is when you start looking at the changes in time, there's some really interesting data quality observations you can make with between the anomalies, conflicts. Like sometimes data producers will change. One example, there is a data producer, I can't name names, that changes every other Friday the name of their company from 21st Century Fox to like 21st Century or something for a period of a couple of hours. And I kind of chuckle at it because it must be some process that's behind the scenes that changes it, distributes all that data, and there's some other post correction that's made to it. But that's just an example. That's an insignificant example because it's non-material since it's just the name change. But if it was a change to something that was significant, a price or something else, that would be a problem. Right.
Good example, clear example. And in case it isn't obvious to the listener why this is so absolutely critical important, all these ideas around when we know information, when it's official, when changes happen, a big reason why this is so absolutely important is that when you are a quantitative trader, a systematic trader, and I was one professionally for a couple of years, you design your trading strategies based on historical data. So you have, so your algorithm, you design these algorithms that use some kind of modeling, some kind of understanding of the market to try to predict based on this information that I have, is the price at this instant of this particular stock or commodity or whatever, is it likely to go up or is it likely to go down? How
Yep.
likely is that? And depending on how likely it is, then maybe I'll trade on it or not. And especially when you're trading at high frequencies. So a lot of our algorithms were sub-second, where you enter into and out of a trade. So you buy a product and sell it in less than a second.
Yep.
And I'm talking like fractions of a second, hundredths or thousandths of a second. You're in and out. When you're talking about that kind of resolution, or maybe not even that fast, even just minutes or hours, if you don't know exactly what information you had at that instant, then you can design an algorithm that, unbeknownst to you, when you're training it on historical data, it can see into the future.
Yeah.
So, of course, it's an amazing algorithm because it has information that you didn't really have until minutes later or a day later.
Yes.
And so you could end up training your algorithm. You could say, wow, this algorithm, when I deploy it into the market, it's going to crush better than any algorithm I've ever had. I'm going to be so rich. But then you just get eaten alive.
It's look ahead bias, right? Yeah. I mean, that is that's one of the most critical problems. And then there was something else that you said that I wanted to add on to, which is You mentioned high frequency. And that's another, when we think about the segments of the financial markets, that's a whole other area, like of all these different investors where they are making decisions sub-second, millisecond, microsecond. Actually, one particular area that is very interesting for the audience is to read up on transaction cost analysis within the trading departments of companies, because that is an area where there's high frequency companies, and then there are I don't know if they call themselves low frequency, but they don't trade as often as basically high frequency. I don't think they call themselves low frequency.
It doesn't sound very cool.
Doesn't sound very cool. They just don't trade as often. And in those kinds of organizations, sometimes you need to spread out a trade over hours, days, sometimes even weeks. And it's important because the price can move, that you need to have a way that you can look back and identify, could there have been another way to make this trade that would have been more profitable? So that area of transaction cost analysis has been critical over the last 10 years, and it continues to be an area that I've seen organizations kind of tune in a little bit more to now that there's better technologies. And that's where you can have, just to recap, you can have companies that are not trading as often, but rely upon like this intraday data, or you can have TCA being taken into account as part of the sub-second processing.
TCA?
Yeah, TCA, transaction cost analysis.
Oh, right.
Yeah, sorry. Yep. Yeah.
Cool. Well, so lots of interesting, complex problems that you've touched on in this episode. If somebody wants to work with you, if there's a listener out there that's thinking, sounds pretty cool, I have a relevant background, or I have a highly technical background, and I'd love to be moving into this kind of financial data engineering.
Yep.
You have 4 data engineer roles open right now.
Yep.
So there's an opportunity right there for some listeners. How can people apply?
Just getting in contact. I'm big on LinkedIn, so if they just contact me through LinkedIn, I'm actively communicating on there. But that would be terrific. And what's important to us as a company is really passion. Like, that's one thing that I think is critical for whenever I'm looking at hiring. Is I want to see someone's passionate about what they do. And that could take the form of, contributing to open source projects, and just keeping abreast of the new technologies that exist and how to be able to apply them. And just sometimes also having a good attitude as well too.
Nice, yeah. Passion and attitude.
Yeah.
So, all right. That gives us, so typically the last question I ask is, how should people stay in touch? But you just answered that, which is LinkedIn. And so then my final question, which would typically be my penultimate question, is, do you have a book recommendation for us?
I do, actually. And in not kidding, like, there are so many different books that I can recommend. There is one book in particular that I really have loved. And it's actually called Chasing Excellence by Ben Bergeron.
Oh, yeah. All right.
Great book. Even if you are not someone, he's a CrossFit coach that has gained sort of a lot of recognition in CrossFit because of the games and everything. Like,
he coaches some of the biggest names. So early on, his wife Heather Bergeron was big in the games, but he, in more recent years, some of the very best CrossFit athletes, Katrin David's daughter, Matt Fraser, trained with Ben Bergeron too, right?
Yeah, yeah.
So yeah, 2 of the most accomplished CrossFit athletes of all time. So amazing. And Doug works out in Ben's gym, CrossFit New England. And I discovered just before the show, lives just a few blocks away. So in the small chance that you're a super data science listener that's into CrossFit as much as me, this is really exciting. And I actually didn't even know about Ben's book, Chasing Excellence. So
Yes.
what's it about? So it's not even just for CrossFit people, I think was the point
Well,
that you were
yeah,
about
I mean,
to
I
make.
think my point of view is that even if you are not someone that's into CrossFit, understanding the mind of an athlete and the discipline that they have and just their way of thinking, um, a, a lot of it that I took away was approaching whenever you have a problem with you have a problem, here's a solution. If you're not happy with, let's say, they gave an example of a time or a score that you got, right? Let yourself be angry for 5 minutes, 10 minutes, 15 minutes, but then move on, move past it at that point. Don't think about it again. Give yourself several days, then reflect on it. Things like that, I feel like really help, even if it's applied in that scenario to an athlete, it helps in our day to day. So that's a great point.
Nice. Really great recommendation. I love that, Doug. All right. Thank you so much for being on the program. I've learned a ton. You are an outstandingly clear communicator of concepts, and you give such rich examples. So I'm sure our audience loved this episode as well. Hopefully, we can have you on again sometime.
Yeah, sounds great. I would love to do that. And I'd love to talk more about data, my passions of data engineering and finance.
Love it. All right, Doug. Catch you again. Bye-bye.
Thank you.
Told you Doug was a clear, content-rich communicator. I learned so much in this episode, and Doug made it so easy to understand thanks to his clarity and bountiful examples. The key points Doug covered were how to start a consultancy with no track record, how the best way to launch software products could be via consulting, an overview of the major financial industries like capital markets, asset management, and high-frequency trading, an overview of the front, middle, and back office financial firm structure, how data engineering for front office decision-making is extremely complicated because it involves the integration of hundreds of data sources, each with retrospectively updated data points, and how entity resolution, knowledge graphs, and tri-temporality can address these issues. As always, you can get all the show notes, including the transcript for this episode, the video recording any materials mentioned on the show, and the URL for Doug's LinkedIn profile, as well as my own social media profiles at superdatascience.com/485. That's superdatascience.com/485. If you enjoyed this episode, I'd of course greatly appreciate it if you left a review on your favorite podcasting app or on the Super Data Science YouTube channel, where we have a video version of this episode. To let me know your thoughts on the episode, please do feel welcome to add me on LinkedIn or Twitter and then tag me in a post to let me know your thoughts on this episode. Your feedback is invaluable for figuring out what topics we should cover next. I'd like to give a special mention to those of you listeners who nominated my work for a Data Community Content Creator Award. Thanks to you, at the award ceremony on June 22nd, my YouTube channel was recognized as the favorite for learning about machine learning and artificial intelligence. If you haven't checked it out yet, the channel's at youtube.com/c/JohnCroneLearns. We upload a new video every Monday and every Thursday. I'm absolutely delighted that some of you think we're on the right track with the ML AI videos we publish. All right. Thanks to Ivana, Jaime, Mario, and JP on the Super Data Science team for managing and producing another amazing episode today. Keep on rocking it out there, folks. And I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.